go. Okay, so yesterday you should have received two different formulas. One was the derivative of a to the u. What is the derivative of a to the u?
A to the u times
Adam?
A to the u times derivative of u times natural log of
U prime.
Times what?
natural log of
Good. Itself times the natural log of the base times the chain. Okay, that's all that u prime is, the chain. If you prefer, some of you might like it better in this form. It's the same thing. Okay, the du dx is that chain element that you need when taking the derivative. Okay, that's one of them. The other one was the derivative of a log base a of u. I think that's right. Yes?
Yeah.
Good. Okay, what's that? John?
u prime over u times 1 over log of the base, natural log of the base.
Or if you prefer, 1 over u times 1 over the natural log of a times du over dx. Excuse me. And again, where du dx is the chain of that. And as much as I'm not a fan of memorizing, this is these three formulas, I got one more for you today, are easiest if you just memorize them. Okay, instead of deriving them every other time or every time that you have to use them, I think it's easier to just add those to a note card and then burn them into your brain. Okay, today we're going to get the third one. Real simple lesson. I'm going to give you the formula. We're going to work through an example or two, and then we'll be good to go. So the formula for today is the integral. So we're going to do the integral of a to the u du. So this is a constant raised to a function. Sometimes that function will just be x. Sometimes that function will be something more complicated. That's equal to itself times 1 over the natural log of a plus c. Now the one thing that's not up there that you need to take into account is if u is something other than x, they have to be done without exceptions as u du problems. And what you should have found on the homework, or what you should have realized in the last couple nights of homework, is that if you don't do it as a u du, you lose a constant that shows up out in front of the integral. Okay. What I mean by that is people have a tendency to look at this like, okay, I'm taking the integral of e to the 3x squared. Well, e to the 3x squared, the integral of e to anything is itself, and then you just stop. But it has to be done as a u du. And I'll show you in an example. Okay, we good? Example number 1.
Go back. Thanks. I thought you asked me if we were good at
I was just concerned about your well-being. I don't care about the calculus. Everybody good?
this. Yeah.
All right, good. Okay. No, you're okay. She didn't eat lunch.
So for
She's tired. She's
I had
chipper.
limonades for lunch.
for the first two classes,
Yeah.
how do you know like
Yeah.
when you use one versus
I'm going to do an example on the homework where we'll look at all the different scenarios so that you can figure out which one you use. I think it's 93
You
for my
definitely hit
second.
like a point about snag, you're like,
Right, now what? Yeah, we'll talk about that. Okay, so let's start with something easy.
Says it all the time. Every time I the cheese, or like less.
It's
I know. I'm not. It's kind of like sarcasm still.
Because this section is just about the same thing over and over again, that same thing being a constant raised to a function, it's pretty easy. Where it's going to get more complicated is when we get into functions or problems where it could be a function raised to a function, it could be a constant raised to a function, it could be a constant raised to a function raised to a constant. And I'll do one of the examples from the homework last night where all of those are outlined. But in this case, we have a constant raised to a function. It is a UDU problem. What would U be? Negative x. So du is equal to negative dx. So dx is equal to negative 1 du. So this becomes the opposite of the integral of 3 to the u du. And as I mentioned earlier, if you don't do it as a u du, you will lose that minus sign, which is crucial in solving the problem.
So everyone has a
There you go. Yo.
So when we do something like this, it's the same thing with like, you can't have any x's left, correct?
Right. Same rules apply, no u's and x's combined. If you did, you made a mistake.
Okay.
Okay, then you invoke the formula itself times
The net 1 over the natural log of itself, or a.
all done. Okay. I got one more example for you, and then we'll take a look at homework problems.
So this is literally all just like plugging in.
What's that?
This is all basically plugging in.
Yep. That's a 9, by the way. Somebody in 4th period was obsessed with that being a Q.
How is that?
I don't see it as a Q.
Well, I mean, if
You're asking me to
not-
explain somebody else's example.
If you
However, I will say this, it led into an interesting conversation. Suppose it is a Q. Okay, we'll just pretend. Suppose it is a Q. What can you tell me about Q then?
It's a constant,
It's a constant. There you go. How do we know that?
because f dx.
Right. That dx tells me that anything in that equation other than an x becomes a constant. So it wouldn't change the problem. You would just change 9's to q's and you're good to go.
What is like dx dq then? Like,
What if it was a dq?
Oh, okay, dx.
Then we eat ice cream.
But
That's so funny.
So I'm gonna solve it.
did you use that?
If it's a
formula?
dx,
And dq.
Is that
multivariable calculus.
Oh, it's a
Single variable
Oh, what
calculus.
he's saying.
Oh, is that why our textbook is called that?
There's a whole nother branch of
That's
calculus
such a
which is
great-
multivariable where you have
When do you do that?
never in here.
Well, I mean, like.
College.
Is that calc?
But what majors do that?
Calc majors,
That's it?
no, math majors, engineers probably. Most of the hard sciences. What are you going to study next year?
Engineering.
You're screwed.
So you'll do calc, you'll probably get out of calc 1, you'll have to do calc 2, you'll have to do calc 3.
Maybe I can just not.
Maybe, you might not have to do multivariable. You'll definitely have to do differential equations. You'll be fine.
Can you do multivariable calc?
I'm good at.
It's been too many years now. I'd like to tell you, yeah, no problem, but I wouldn't know where to begin.
Could you try?
Huh?
Could you try?
No. I got other things to do than reteach myself multivariable calculus. All right, what's U?
4x to the
that's it.
5th plus 2
That's
minus
it.
multivariable calculus.
Okie doke. This is good because the x to the 4th down here cancels with that x to the 4th. We get a 1/20th out in front, and we get 9 to the u du. 1/20th. What's the antiderivative?
9 to the u.
Over natural log.
9 to the u times,
1 over natural log.
good, plus c. So 1/20th times the natural log of 9 times 9 raised to the 4x to the 5th plus du plus c.
What about?
What
oh,
about
we
what?
already did.
Yeah, I just combined it into one term, because it's a constant, so just
Do you
throw it.
have to?
You don't have to do anything, this is America.
That's true.
That's far
U
right
looks
on.
like a 4.
Yeah, you done.
What looks like a 4?
9 to the U, it looks like a 4. We should work on that.
All about perception.
I wrote 4 then.
Yeah, why didn't you have tails on them?
But you know it's a U, right?
I wrote it down 4.
No, it's
And I was
you.
like, that doesn't make sense.
Why you
Rounded.
Yes, John?
Do we have to leave it like that, or can we just write 9 to the 4x with the plus 2 over?
What is
1
that?
to the natural log?
Yeah, you can combine it, it's up to you. Yeah, it's the same value. Adam,
Why isn't the 9 over 20?
say again, I'm sorry?
Why isn't the 9 over 4?
You can. John just asked the same question. I could write it as, I could take this thing and put it up in the numerator if I wanted to. I just left them as two separate numbers. Is that what you're asking?
Yeah, it's not crazy. Why is it like 4 is like?
Get the 9 over, like the 20 under.
Why does it 20 just go over the math?
My notes yesterday are 2 elements.
Why is the thing that gives you front
Wait, I can't hear you. Shh.
Sorry.
I'm sorry.
Why is the thing that gives you front integral only multiplied to the natural log? And not like the 8?
The 120.
I'm confused.
Let's talk about the 120. Why does it like? Why is it?
Alright, so 120, why is it not under, like, why is it not 9 over 20?
Because there's like 120 to the front integral.
This guy?
Like the step before it.
Why isn't this 9 raised to the 4x5 plus 2 over 20 as well?
It
Are
could
you
be.
saying why can't you just put the 9 4x over 20?
You can. Yeah, it's the same thing.
It's a miracle.
Yeah, 1/5 times 7 is the same thing as 7/5. It's just a matter of how you want to write it. Yeah. Okay. Did I answer your question? Come on.
Go. It's all you.
Alright, so you got this. Why does this just go here and not, why is it not like that?
It can.
Why is
Isn't that changing it?
It doesn't
Well,
matter.
it depends on what you're raising to that. This is okay.
And then you have to get rid of the
You got to put the whole thing up on top. It's not this. This bad math. Okay. So, you can rewrite that the other way if you want. That's cool.
Go you.
Okay.
Are we done now?
Yeah, we're done.
Once you're there.
Yay.
So let me stop recording and then we'll take a look at, let's start with problem 93 from last night's homework.
Okay.